Okay, so this is a small theorem. Suppose that A and B are independent events. We want to prove that A and B complement are also independent. So what's given is that the probability of A and B is equal to the probability of A times the probability of B. And what we want to show is that the probability of A times B, the probability of A intersect B complement is equal to the probability of A times the probability of B complement. So that's the idea of where we want the proof to end. To do this, we will use the law of total probability, that the probability of A is equal to the probability of A intersect B plus the probability of A intersect B complement. And this is the principle behind many of the tree diagram problems that we've seen already in this series of videos, where B would be the first branch of a tree diagram and then A would be the second branch. Okay, so let's use this principle, and we'll notice that this is right here, the left-hand side of what I want to show. This right here is given here, so that the first term over here is the probability of A times the probability of B. Now the left-hand side over here is magically sitting here, so I want this to stay put, and I want these two terms over here to end up to be equal to this. So to make that happen, let's move this term over to the left-hand side. So the probability of A intersect B complement is equal to the probability of A minus the probability of A times the probability of B. Now I want to make this look like this. Clearly, one thing I can do is factor out the probability of A, and that leaves me 1 minus the probability of B. And of course, 1 minus the probability of B is the same thing as the probability of B complement. And so we conclude that the probability of A intersect B complement is equal to the probability of A times the probability of B complement, and so that is the proof.